All right, if you have a sweet tooth, you're going to like this one. So we're solving systems of linear equations, so let's get right into the application and we'll see how that linear system comes into play. So Sean bought 1.8 pounds of gummy bears and 0.6 pounds of jelly beans and paid $10.26. He went back to the store and bought 1.2 pounds of gummy bears and 1.5 pounds of jelly beans, and he paid $15.09. What is the price per pound of each type of candy? So we're asked, what is the price per pound of each type of candy? So let's talk that we've got gummy bears and we have jelly beans. So let's say the price per pound of gummy bears is going to be G, and the price per pound of jelly beans is going to be J. So let's figure out some of our equations. Well, we have this first week, Sean went and bought 1.8 pounds of gummy bears. So how much would he have paid for those gummy bears altogether? Well, he bought 1.8 pounds, and then he would have paid the price per pound multiplied by that, right? We would multiply 1.8 times how much it costs for each one of those pounds. We have 1.8 pounds multiplied by however much they charge per pound. That's going to give us our total price for our gummy bears for this trip. And then we're going to add that to our total price for the jelly beans for this trip, which he bought 0.6 pounds of gummy bears, or of jelly beans this time. And of course we don't know how much he paid per pound, but when we multiply how much he bought by how much they are per pound, we're going to get the total price. So this is the total price he paid for gummy bears on this trip, the total price he paid for jelly beans on this trip, and when we add it together, we get $10.26. So let's take a look at the other trip. He bought 1.2 pounds of gummy bears this time. So we take 1.2, we multiply it by how much it costs per pound for each one of these pounds. We want to multiply by each one of these pounds costs the price per pound. So when we multiply that price by how much he got, that tells us how much he paid total for gummy bears on this trip. And then we're going to do 1.5 times the price of jelly beans on this trip. And so this is the total he paid for the gummy bears on this trip. This is the total he paid for jelly beans on this trip. And we come out to $15.09 for this one. So let's take a look at how we can possibly solve this with graphing. So here's a little graph paper here. Let's take a look at what we need to do to graph this. So when we look at this, what we're saying is if I went to the store and I bought 1.8 pounds of gummy bears and 0.6 pounds of jelly beans, there's lots of different combinations of prices that could happen that would get me to $10.26. I mean, truly, these could be free. These were like on a promo deal, and I just paid for these. Or these were free, and I just paid for these. Or there could be any combination. These could have been 10 cents, and there's lots of combinations along this line. Where this line goes, any one of the points on that line is a solution. So that tells me any point on this line satisfies this equation. And same thing here. Any point on this line, when I graph it, is going to satisfy this equation. What we're trying to figure out is what point on these two lines satisfies both equations. Because the price of gummy bears and the price of jelly beans didn't change in between trips. So I know that this G is the same as this G, and this J is the same as this J. So what I'm trying to figure out is what point on these two lines is the same, and what point satisfies both this equation and this equation, and so it could be a solution for both. So let's take a look at this. So we are going to number this number line here. We're going to start at 0, 0 because you can't have a negative price on these items. And we're going to say that this axis down here, our X, is our gummy bears, and this axis here is going to be our jelly beans. So we'll just do 1, 2, 3, 4, 5. There we go. 15, 16, 17. 17, 18, 19, and 20. And then we'll do the same here. All right, so here is our graph, and let's figure out where our points on our lines are going to go. So these ones are in, well, they're not quite standard form, but close enough. And so we're going to use the cover-up method to figure out where they belong. So for this equation, again, let's say the gummy bears were completely free, and I got those for $0. Well, then if I take G and multiply, and plug in 0 for G, when G is equal to 0, I have 10.26 divided by 0.6, and what I end up with is 17.1. So that would say if the gummy bears happened to be completely free, then I would have paid $17.10 for each pound of jelly beans, and that would have gotten me here. So we're going to graph that one. If the gummy bears are totally free, and they are at 0, then my jelly beans are going to be $17.10, which is just right up there. Now, if my jelly beans were completely free and all I'm paying for is the gummy bears, then I would get $10.26 divided by 1.8, and that's going to tell me that it was about $5.70 for each pound of gummy bears. So I can say if jelly beans is at 0, then gummy bears is at $5.70. So those are my two intercepts. And I can go ahead and graph that line. Through those intercepts. And again, we're not using any of the negative quadrants because it's impossible for us to have a negative price for these gummy bears and jelly beans. Nobody was giving them away to me or giving me money back for them. So these are really our only solutions. All right, now let's take a look at the other ones. This one would say, okay, if the jelly beans, no, let's say if the gummy bears were completely free and I bought 1.5 pounds of jelly beans and it cost me $15.09, what did I pay for the jelly beans? Well, we divide both sides by 1.5 and we end up that the jelly beans would cost $10.06. So if gummy bears is equal to 0, jelly beans is equal to 10.06, which is right there on 10. And then if jelly beans were 0, if they cost me nothing and I just paid for the gummy bears, then I'd have 15.09 divided by 1.2 and I ended up with 12.575. So jelly beans are equal to 0, gummy bears would be 12.5 right there. Okay, so we're going to graph this line, and again, any of these points on this line would satisfy my equation. They could have given me the gummy bears for free, and I just paid $10.06 for the jelly beans, or vice versa. But there's only one point that satisfies both of these equations. There's only one point that makes both of these true, and it is right here where they cross. This is one of those instances that solving algebraically is going to give us a more precise answer, but graphing is going to give us a really good idea of where we're at. So we're somewhere around $3 and 20-ish cents, $3.50 possibly for the gummy bears. Yeah, right about there, about $3.20. And then right here in the middle of 7 and 8, so I'm going to call that $7.50. So if you solve this algebraically, you would actually find that this point is $3.27.50, but we can see that. So that means that we paid $3.20 for every pound of gummy bears, and we paid $7.50 for every pound of jelly beans.